Hello viewers, you are welcome to my page. This is another questions on isomerism, and it says draw the structures of the possible isomers of pentane. Draw the structures of the possible isomers of pentane. Like I explained in my last video, that the word isomers is an organic term and it is derived from isomerism. It is derived from isomerism. Then isomerism has to do with occurrence of two or more organic compounds with the same molecular formula but different structural formulae. Occurrence of two or more organic compounds with the same molecular formula but different structural formulae. Then we are looking for the possible isomers of pentane. That is, we are looking for different structures of pentane from the molecular formula of pentane. So we need the molecular formula of pentane first. So we are going to need the molecular formula of pentane. So what type of organic or the class of organic compound is pentane? So to know the class of organic compound, you consider the name ending. So it ends with "ane". So the ane members are alkanes. The anes members are alkanes. So it shows that pentane is under alkane, is a saturated hydrocarbon called what? Alkane. Now, we have members of alkane. The first member is methane. The second member is ethane. The third member is propane. The fourth member is butane. Then the fifth member is pentane. So pentane is the fifth member. Pentane is the fifth member. So the molecular formula of pentane can be derived from the general formula of alkane, which is CnH2n plus 2. So whereby n will be the number of mole. For the first member, n will be 1. The second member, n will be 2. The third member, 3. The fourth member, 4. The fifth member, 5. Pentane is in number 5, so our n will be 5. Let's substitute this 5 into this general formula. That will be C times 5 will give me C5. 2 times 5 will give me 10. 10 plus 2 will give me 12. So that is H12. C5. So this is the molecular formula of pentane. Now, to know the number of possible isomers that we can derive from this molecular formula, I'm going to use formula method to calculate the number of possible isomers that I can derive from this molecular formula. So, and the formula is 2 raised to power n minus 4 plus 1 equal to, then our n will be the number of carbon atoms. So we have 5 carbon atoms. That will be 2 raised to power 5 minus 4 plus 1 equal to 5 minus 1 will give us 1. That is 2 raised to power 1 plus 1. Any number raised to power 1 is that number. So that is equal to 2 plus 1 equal to 3. So it shows that we will be able to derive 3 possible structural formulae of what? Of pentane from the molecular formula of pentane. So what will be the first structural formula? What will be the first isomer? So the first isomer will be the normal structure of pentane. So you are going to join these carbon atoms together with what? With covalent bond. So you are going to draw a continuous chain with these 5 carbon atoms. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the number of carbon atoms joined together by what? 1 covalent bond. Since they are under what? They are under alkane. So under alkane, the carbon atoms are joined together by 1 covalent bond. So now after that, you fill what? Each carbon atom with what? With chemical bond. Because each carbon atom must be surrounded with 4 chemical bonds. In organic chemistry, each carbon atom must be surrounded with 4 chemical bonds. So we are going to surround each carbon atom now. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then you fill with hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So which is equivalent to the number of hydrogen atoms that we have from the molecular formula. So this is the first isomer. Then it is named pentane because it is the normal structure of pentane. Now, to derive the next isomer, so you are going to reduce the length of the chain by 1 carbon atom. You reduce the length of the chain, that is, you remove 1 carbon atom. So when you remove 1 carbon atom, you will be left with 4 carbon atoms. 1, 2, 3, 4. So the carbon atom that you remove will go with what? All the hydrogen atoms that surrounded it. So if you are removing this carbon atom now, it will go with 3 hydrogen atoms. Shows that you are removing CH3. C and hydrogen, 3 hydrogen atoms. CH3 is called what? Methyl. CH3 is called methyl. Methyl is an alkene, is under alkene. Methyl is under alkene. Then methyl is always substituent. So you have removed CH3, that is 1 carbon atom with what? With 3 hydrogen atoms. So the rule is that you can place this CH3 on any of these carbon atoms, but you must not place it on the terminal carbon atoms. You must not place it on the terminal carbon atoms. Then what are the terminal carbon atoms? They are the carbon atom at the right and are the carbon atom at the left. So you cannot place this CH3 on the first carbon atom at the right. You cannot place it on the first carbon atom at the left. But you can place it on any other what? Carbon atom. So CH3 now, I can place it on this second carbon atom. CH3. So this is another isomer. So fill your what? Fill your carbon atom with chemical bond. 1, 2, 3, 4. So fill with hydrogen. 1, 2, 3, 4. So fill with hydrogen. Then likewise this one. 1, 2, 3, 4. This one needs one more hydrogen atom. 1, 2, 3, 4. So fill with hydrogen atom. So this is another isomer. This is another isomer of what? Of pentane. So the name will be totally different from what we have here. The name will be totally different from what we have here. Then let's consider the definition of isomerism. It says that they will have the same molecular formula but different structural formulae. Do they have the same molecular formula? Let's check. For this one, how many carbon atoms? 1, 2, 3, 4, 5. C5. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen atoms. So let's check the next one, the next isomer. Do they have the same molecular formula? Because they must have the same molecular formula but different structural formulae. So let's count the number of carbon atoms. 1, 2, 3, 4, 5. C5. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 3 will give us 12. So they have the same molecular formula but different structure. So let's name the structure of this second isomer. Let's name the structure of the second isomer. So under naming of organic compound, so you select the longest continuous carbon chain first. So let's select the longest continuous carbon chain before we can name. So 1, 2, 3, 4. This one, 1, 2, 3. So we select the longest one. So this is the longest one. 1, 2, 3, 4. So you number from both sides, from the right to the left, then from the left to the right. 1, 2, 3, 4. So you consider your substituent. So you are going to name from the side where you have the least to the first carbon atom. That is where your substituent is very close to the first carbon atom. So from this side, this is my first carbon atom from this side. 1, 2. my substituent is on the second carbon atom. So if I count from this side, 1, 2, 3, my substituent will be on the third carbon atom. So you count from where you have what? The least to the first carbon atom. So the best way to count, or the best side to count, is from the what? Is from the right to the left. So my substituent is on the second carbon atom, CH3, which is called what? Methyl. So what will I call it? My CH3 is on the second carbon atom. I will call it 2-methyl. 2-methyl. Then after that, you name your what? Your root hydrocarbon, the longest continuous carbon chain. You're having 4 carbon atoms. You're having 4 carbon atoms. So an alkane with 4 carbon atom is called butane. Don't forget that the first member of alkane is methane. The second member is ethane. The third member is propane. The fourth member is butane. So alkane with 1, 2, 3, 4 with 4 carbon atoms is what? Is butane. So your root hydrocarbon, which is the longest continuous carbon chain, is butane. So the name of this structure is 2-methyl butane. So we have derived another isomer. Don't forget that we must derive 3 possible isomers. We must derive 3 possible isomers. Then the third one. So from this one now, you are going to reduce the length of the what? Of the chain by 1 carbon atom again. You are going to reduce the length of the chain by 1 carbon atom. Now, if I remove from this side, if I remove this CH3 from this side, so CH3 will be on the first carbon atom here. If I remove this CH3, don't forget that the carbon atom that you removed must not be on the first carbon atom at the right. It must not be on the first carbon atom at the left. So if I remove this CH3, this CH3 will be on the first carbon atom, which is not what? Which is not possible. So I'm not going to remove from this side. I'm going to remove from this side. So if I remove this CH3, I will be left with 1, 2, 3. 3 carbon atoms. So the next possible isomer so the next one, 1, 2, 3. So 3 carbon atoms now. 1, 2, 3. So on this carbon atom at the middle, we have this CH3 there already. So place your CH3. Then you have removed this CH3 now. You have removed carbon atom now with the hydrogen atoms that surrounded it. So I'm removing another CH3. I'm removing another CH3. And the rule is that you must not place it on the first carbon atom at the right. You must not place it on the first carbon atom at the left. You must not place it on the first carbon atom at the right. You must not place it on the first carbon atom at the left. So another CH3 that you remove now, the only option is this carbon atom at the middle. So you are going to place it on this carbon atom at the middle. That's CH3. Then you fill your carbon atom with what? With covalent bond. 1, 2, 3, 4. So fill with hydrogen atoms. Then 1, let's look at this one. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. So fill with hydrogen atoms. So this is another structure of, this is another isomer of what? Of pentane. This is another isomer of pentane. So let's confirm. Maybe they have the same molecular formula. Let's count. 1, 2, 3, 4, 5. 5 carbon atoms. Let's count the number of hydrogen. 1, 2, 3. So 3 plus 3 will give us 6. 6, 7, 8, 9. 9 plus 3 will give us 12. So they have the same molecular formula, but we are having different structures now. So let's name this structural formula. Let's name. So you select the longest continuous carbon chain. 1, 2, 3. This is another one. 1, 2, 3. This is another one. 1, 2, 3. So let's pick this one on a straight line. 1, 2, 3. So we are going to name our substituent. This is our root hydrocarbon, the main hydrocarbon. Then all these are substituents. All these are substituents. Then don't forget that CH3 is methyl is methyl, is called methyl. So CH3, the two CH3 are methyl. So what will be the name of this structure? 1, 2. The first methyl, we're having two methyl now. The first methyl, the one up is on the second carbon atom. The one up is on the second carbon atom. You call it 2, comma. Then we have another methyl. We have another methyl still on the second carbon. Another 2 for the second methyl. How many methyl? That's 2. 2 means di. So I'll call it dimethyl. Dimethyl what? Then you name your root hydrocarbon, which is the longest continuous carbon chain. 1, 2, 3. That's 3 carbon atoms. So the analkane with 3 carbon atom is called propane. So 2,2-dimethyl what? Propane. Then don't forget that our formula method says that we are going to have 3 possible structural formulae of pentane. So this is the first one, this is the second one, and this is the third one. So this is where we are going to stop for today. Don't forget to subscribe to my channel. You join me on YouTube. If you are here on TikTok, click on the link in my bio. It will take you to my YouTube channel to access full video on this topic. Then if you are watching me on YouTube, remember to subscribe. If you are new here, subscribe, like, share, and leave comments. Bye.